I think we're good. So welcome to CS235, Applied Robot Design for Non-Robot Designers. This is Solidworks Training Session 3. We're going to be going over some of the work for Lab 1. So everybody go ahead, boot up Solidworks, make sure you're online, and navigate to the starter files for Lab 1. This is the stuff I emailed out last night. And let's see. Let's go ahead, open up helical, rush gears, and do the one that ends in R, just the SolidWorks part. You don't need to do feature recognition, that's fine. Can everybody hear me okay? Okay, so the first thing we had to do in the homework is that basically we can't make an assembly until we have parts to assemble. I didn't include you sufficient parts to start assembling just in the starter file. So everyone to an internet browser and browse your way to McMaster. Now I'm going to open up the instructions for this. Okay, so the first thing we're going to do is download a screw and a nut just so we have something to work with. So go ahead and copy the number from your instructions. Yeah, would you like me to read that number aloud so you don't have to open that up? 90710A030. Type that in. So this, everybody see this button down here? Let me start out. Has everyone already done this?
Oh, yeah.
Appears not. Okay. Press on the little cat icon. Select 3D SolidWorks. Select Save. Save it to the file, to whatever folder you're in. Okay, and I'm going to do it again for a 12mm screw. So the 12mm screw has a part number 91290A117. Again, press the CAD button in the lower left of the pop-up. 3D SolidWorks, save, and then save it to your folder, and you probably want to name it something like this, M3 by 12mm by part number. It's fine for now, just so you know what it is. Okay, does everyone have the screw and the nut downloaded? And can someone tell me? Not yet? Okay. When you do, let me know. Remind me your name one last time?
Niels.
Niels, okay. John, Alex, Yee? Alex, okay. Alice, Michelle, Shruti, John, right? Okay. Shruti, John, Alice, Michelle, okay. Niels, Alex. Okay, everybody got the CAD? How's it coming, John? Okay. So go ahead and open up the nut. Go ahead and open up the screw.
So which brush gear do we open again?
The one ending in R for right. Helical. And then do the one ending in R.
Okay, and no feature recognition.
Yep.
Which screw is it?
Do an M3 by 12. This is the inevitable setup. How many of you guys were at the Friday session?
Thursday was the first.
We did one on Thursday.
Oh,
We did one on Thursday night and one on Friday afternoon.
That was on Thursday.
Were you there? Jonas! Okay, everybody got the screw in the nut? Okay. Jonas, the first thing you need to do is download an M312 screw and a nut from the homework instructions.
Right.
Okay, so, and you can basically, the only thing we've made in SolidWorks thus far is a part. Now we're going to make an assembly. Go to File, New, and see in my screen it says Part Assembly Drawing. You're going to click Assembly and hit OK. Now see, there will be a Begin Assembly thing. Just hit X there. So first, what is an assembly? Can anyone tell me? An assembly is some collection of individual parts. A part's one part, an assembly is several of them, or more than one. So the first thing we need to do is put our base part. That's the first part. See this button here, Insert Components? Press that. And now you'll see here it gives you three options, the three parts that are open. Okay, now it will always give you the options right here of any file that is open. However, if you have 10,000 parts in your robot, in which case I feel sorry for you, they're not going to all be open at the same time. So it's actually safer to hit Browse, and now we see all of our parts in our folder. So go ahead and select on that helical rush gear ending in R, the right one, and hit Open. Now see here how I can put it anywhere? Just put it somewhere and it comes back to center. Now let me know once everyone has put that gear there.
So, this is redundant, but so I just got the Windows ever, so I'm trying to just unzip the zip thing.
Yeah.
And make this WinRAR.
Uh-huh.
I guess I'm confused by the interface. Like I keep unzipping an empty folder and just prompting me for like a encryption password.
Yeah. Did you give the password?
Oh, sorry, I didn't realize there wasn't.
Yeah, it's CS235 _rocks _ my _ world. This is my weak attempt at humor at 2:30 in the morning.
I like the fact that we send it out to
Okay. Should I go ahead? I don't want to leave half of everyone behind. Okay. So this gear, click it and try to drag it around. And it will tell you the selected component is fixed, it cannot be moved. The first part you put in assembly is always fixed. It does not always fix it intelligently. One would hope that it aligns all of the planes properly. It does not. And remember how I said that you never, ever, ever in a billion years want to fix anything in SolidWorks? The first thing we're going to do is undo that. So click on the part in the window in the Explorer to the left, right click, and you see where it says float on my screen? Click float. It is no longer fixed. So now you can move it anywhere you want. And if you want to test, you can right click it again, and now it says fix. We can refix it, but that's bad. So make sure it's floated. Okay? Things get weird when your parts don't align, at least any of them, in terms of their planes within the assembly plane. So let me explain that real quick. Everyone see my screen? These are the assembly, let me zoom out. These are the assembly planes. Okay? And now under my part, I have my part planes. They're different. We should align them. So if I look here, I can click on two of them. See how my two front planes, my part and my assembly plane, are completely different? Usually you want to align this stuff just to keep it safe. So what we're going to do is we're going to use mates. Mates are the relationships between different parts that constrain the parts. So what I want you to do is don't have anything selected. See this paperclip button called mate? Press that. And it pops up here, and it's going to allow us to make different relationships. See this plus sign here? That allows you to expand the assembly. So now we can click on things. So I want you to click on the front plane of the assembly and the front plane of the part. And see how it automatically moves it to align? Press the green check mark to say yes, that's cool. Now click on the top assembly plane and the top part plane. Green check mark for OK. Lastly, or is there a lastly? We constrained 2 planes. Are we missing anything? Third plane. You always have to constrain 3 planes. Right plane of the assembly, right plane of the part, hit the green check mark, and we're good. So now try to drag that gear around, and it says it's fully defined, it cannot be moved. Okay, go ahead and save it. So whatever you want. I'm going to call mine CS235 RDB helical gear right assemb. Jonas, how you doing on the starter?
It's the helical right,
Uh-huh.
the one with the R in there.
Yep. And John, how are you doing? Here, I'll read you off the part numbers. The first one is 90710A030.
Also, I mean, I guess also I need the file names.
Oh, we've only got 2 for now. Don't worry about it. Okay, for everybody else, go ahead and hit Insert Components again. And I want you to insert the screw. Doesn't matter where you put it. Okay, do you have any weird lines on your screw? See mine? How I've got this hex drawing and I've got these dash drawings? If you have sketches in your part that aren't hidden, they show up in your assembly and they're very frustrating. You click on that drawing, right click, see these goggles? It says hide. Do that. Do that to all of those curves. Just hide them. And if any part of the curve is fine. If you click on a point, if you click on a line, that's fine. And then right click, goggles, hide. Got your parts? Did you download the screw and the nut?
Yeah, it's among all the other parts, right?
Uh-huh. No, I didn't include them. You got to download them. So go to McMaster.com.
Does that actually edit the thing?
No.
Okay, just a copy.
Yep. It just when you hide the lines in the assembly, it's just affecting how you view that part in that assembly. If you were to open that screw, those drawings would still be there. Okay, are you at McMaster?
Yeah.
Okay, in the top left-hand corner, type in 9129A117.
912.
90A117.
117.
And when that pops up, there'll be a little pop-up. There's a CAD button in the lower left-hand corner of the pop-up. Press the CAD button. John, do you have are you ready for the other part number?
Yeah, I mean, I filled it out. I mean, the PDF next one.
Okay, cool. If we get...
One of them, they are hundreds of these.
No. Casey?
Or did I type wrong?
See right here.
Okay.
Okay, and then you select 3D SolidWorks and save.
Okay.
And now we need to do that with one last part. Yeah. Yeah. John, can you please read Jonas the second part number for the nut?
Yeah.
9129081113.
Okay. Oh man, it's angry at me. Okay.
So,
How's it coming, John? Do you have the 2 parts open?
I'm trying to figure out how to save it as
It's probably saving it to your downloads folder by default.
Yeah.
If you look in the lower part of your screen, you can right click and it'll show you where it downloaded. It was confusing me last night as well. Actually, it randomly uninstalled itself. I was really confused. So I think we're going to wait for Jonas and John because I don't want 20% of us to be behind. Did everyone who was ready manage to constrain their gear? Okay, so for those of you who are ready, because I'll probably have to do it twice, you know how before first we pressed the mate and then we selected stuff? We can reverse it. We can also just select stuff and then press mate. So go ahead and select this hole right here and then the outside of your screw head like that. Hold down Control and then press the mate button. You see how it auto aligns there? And press the green check mark. Okay, now watch my screen for a sec. See, it's constrained me to be concentric. I can slide along, but that's it. Now, say we screwed this up and it actually looked like this, which happens a lot. Just press this button. This button just toggles the direction of that. So everybody practice that. And this is a concentric mate. Okay, now rotate your screw so you can see the underneath of the head. Select the underneath of the head, and then rotate and select the bottom of this blind hole right here. Give me one sec. Oh man. Okay, so you're going to select this here, and then that there. And then hit the green check mark. Okay. Jonas, what parts do you have?
I have the screw on there.
Okay, and they're open? Okay. And John, do you have your parts?
Yeah, I got 030 was Solidworks.
Okay. So I think what we'll do is, it's up to you guys, but we have to do this a lot. So I propose that basically all of us who've already done it will restart with John and Jonas, and that'll give us just a little bit of practice. It'll just add 2 minutes, but then we'll all be on board, and it'll give you practice because you know, you're going to be doing this like 90 times for the lab 1. So go ahead and just delete everything from your assembly. It's good practice. Yeah, it's good practice. It's okay. I mean, it is what it is. So everyone should have just a blank assembly open. Is that the case?
Well, when I say delete, they want to delete actual file.
No, just delete the parts out of your assembly.
Yeah, but
So see on my screen, there's nothing over here. John, do you have a blank assembly open? Did your laptop just shut off? Okay, so are we ready to insert components? Okay, press the Insert Components button. Press Browse. Select Helical Rush Gears and select the one ending in R. Hit Open. Place it anywhere. It's fixed, so right-click the gear, hit Float. Now we can move it around. Great. Now expand on the left-hand side the plus mark of the part so we can see its planes and features. Select both of the front planes and hit the Mate button. That looks like a paperclip. Hit the top, both of the top planes, green check mark. Hit both of the right planes, hit green check mark, and we're good. So now we have a gear in the middle, it's fully constrained. Now, insert, component, existing part, and select the screw.
You added to the plus sign in the...
Where?
What do I need to select to get the plus sign here?
Oh, that's only once you're in the mate. Press mate, and then you'll see it.
Wait, so what's that gear for you?
Helical, and then it's the one ending in R for right.
Got it.
Jonas, did you fully power down, or are you good to go?
I'm up and running.
Okay. Does everyone have an assembly with a gear in it? Yep.
How to constrain the
Okay. So is your gear in your file? Right click the gear, and you'll see an option that says float. Press that, and now drag the gear around. You can see it's free to move. Before it was fixed. Now press the mate button here, and then hit both the assembly front plane and the part front plane. And you'll see it kind of move a little bit. And now hit the top plane and the top plane. And finally hit the right plane and the right plane.
It's the front too. I'm not sure what you next. Do I click check? Or?
Whoa, that's a crazy mouse, man. Okay, that's the little plus sign that expands it. How do you click? Okay, what did you press?
So I made it the front planes.
Okay, press top and top, and then do the same for the rights.
Okay.
Where are you, Jonas?
I selected it. Try to mate.
Can you see? Okay, the reason it didn't mate. Okay, if you guys press mate and it doesn't do it, it's because your gear is still fixed, probably. Yeah, see, it says it's fixed. So you right click, hit float. Now it moves around.
Okay.
And now that shows you the planes. So you press that and then control and that, and then this is the mate button. And then you hit the green check mark. In here to select more stuff, you use the plus sign, top, top, and now you do the right.
Which are the two tops here?
These are the assembly planes, these are the part planes.
So you want to make those planes?
Yeah,
That's what you want to do.
so now just do the two rights. Okay, does everyone have an assembly with a properly aligned set of planes? I believe. Has everyone inserted the screw? Just go ahead and put the screw anywhere you want. Does everyone have a screw in their assembly? Jonas? 12. It doesn't matter for now. We just need something to assemble. Okay. Everyone, press the mate button. Select the outside of the head of the screw. Select the whole surface it's going into, and you'll see it move over. Press the green check mark. Now when you drag the screw around, it's constrained to be concentric. Everybody have that on their screen?
Is it okay to press the outer of the hole that it's going into, or do we have to go?
Yeah, that's fine.
Okay.
As long as you know for a fact that that's a concentric hole and you made the part so you know it is.
Okay.
Let me put it this way. Sometimes McMaster parts have very strange geometry. The clamp you guys downloaded has some very squirrely stuff going on. If you were to click random things thinking it was concentric on the clamp, odds are it's not. But you made this part and you can see this part. You can also measure it. Shruti, if you want to see if it really truly is concentric, go to Tools, Measure, and click the outside hole and the inside hole. And you see how it says delta x and z is 0. Distance between central axis is 0. That's how you tell for certain it's concentric. Okay, Jonas, do you have a screw?
Yes, and I made the two faces.
Awesome, okay.
But how do I get in the hole? That's
Okay,
second face?
so now you press mate
Yes.
and press this bottom surface here. Now rotate so you can see the bottom of the screw, and press the bottom of the screw. So now the screw is properly seated,
The bottom of the screw and what?
and the bottom of the hole that it's going into. Here, you want to see again? This right here.
Yes.
Select that and the bottom of the screw, and hit Control so that you get both of them. That one and that one. Okay, and then hit Mate. Okay, is everybody good? Go ahead and open up that nut. Well, actually, no, insert the nut. Again, it doesn't matter where. And then press the little plus sign on the nut so we can look at how it's made. So somebody tell me, we want to do the exact same thing we just did. We want to do a concentric mate with the hole and the nut. What are we going to press on the nut that will allow us to do that?
The service.
There's no circular part in this nut. If you start doing, see this? When I click that edge, it's like a segment of a circle. I don't trust that very much.
What about the inner one?
Which one?
Like the inner side of the circle?
Like the sides of the circle.
That?
Or no,
That?
like the face of the circle, I guess.
This?
Yeah.
No, that won't do a concentric mate.
What about the sides?
The answer is we don't have anything. A lot of the time that you download a part from somebody else, it doesn't have the required reference geometry to do the mate you need. So right click the nut and open it. See how it says older version file on my screen? A lot of the time you download stuff from McMaster, you get that. Just hit OK, it's fine. Select the right, what we need is an axis. So select right and front planes in the nut with the control key, and then go insert, reference geometry, axis. See on my screen? Just like this. And then you hit yes, and I get a little yellow axis there. Sweet. It's right there.
Can you do this within the part file versus something?
Within the part file. Anytime you modify a part, it's the safest practice to modify it in the part. Editing parts in the assembly mode is very tricky business. One of the most common ways of crashing SolidWorks. It just gets very angry.
Ruben, can you repeat the stuff where you're opening?
Yeah. All you do is click it, right click, open. Okay? Does everybody have their nut open? Has anyone made the axis yet? Okay, we'll wait. That's fine. If you want, you can right click it and make it visible, although it might not.
So, what is a mate type? Please select a mate type.
You should be in the nut right now.
Yeah.
Is the nut open on your screen?
Well, I'm that high.
Oh, it's okay. Okay. Is everyone working on their axes? Okay. Oh, you're trying to do this and this?
Yes, and it's just says please select mate type, but it's fine.
No. Here, borrow my mouse. Do you have a USB? Okay, use this. This will be much easier for you. Maybe here, put this over here and then use this.
Okay. How do you add the axis?
Okay.
Just like those opens.
No, hit X. Okay, and click here just to get out. Press right and hold down Control and hit front.
There we go.
No, sorry, front. Okay, now insert. No,
Insert.
reference. Axis.
Got it.
Do you have an axis?
I was just following what you just told her.
Okay, cool. Reference. Axis. Michelle, do you have a...
Yeah, just putting it in.
Okay. You good? Jonathan, do you have an axis?
But do you have an idea what it contains about?
Can I see?
What it says? Please select the mate type.
Oh, can I see for a sec?
Yeah.
first let's make it concentric.
How did you do that?
Here, I'll show you again. Mate,
Yes.
click here,
Uh-huh.
click here. Automatically goes. But now we can't see the surfaces we want. So drag this. Somehow you've already mated that.
Maybe separate one.
You had, the reason was you kept doing the same mate over and over and it was complaining because it had already done it. Now you press mate, press that, rotate, and press that. And then press green check mark. Okay, go ahead and open up your nut. How you doing, Niels? Do you have, yep, you're good. So open up your nut, do you have an axis on it?
I think I do.
So the only way to tell is by expanding it over here.
I think I got 2 screws.
Yeah, you don't have, so
Alright then.
so click the nut and then open. Just the top left. Okay, that's fine.
And then
Now click on right and hold down control and select front. Okay, and now come up here, insert, reference geometry, axis. Jonathan, do you have an axis yet?
Yes.
Okay. So, am I correct that everyone now has a nut with an axis? God damn it, I keep moving my camera. Okay, so, does anyone know how to quickly get back to the assembly?
switching window.
You go Solidworks, window, and then just select the part, the assembly.
You need to save it.
Yeah. Okay, everyone should be back in the assembly now. Okay, on the left hand side, select the axis, and then hold in control, select that hole again, like that. So the hole and the axis. And the only way you're going to find the axis is in the bottom left hand corner once it's expanded, down here. Then you're going to press mate. Look at my screen for a sec. See how this hit coincident? SolidWorks is really irritating. When you do a circular surface and an axis and hit mate, it always tries to do coincident. It might try to do tangent. We want concentric, so you press concentric. These are all different types that we could do. If I press concentric or tangent or coincident, it will try to do them. You want to select coincident and then press the check mark.
Why do I want coincident?
You don't want coincident, you want concentric.
Why do I want concentric?
Because
It's different.
coincident means that axis could be anywhere around that surface. Concentric means the axis is in the middle of the cylinder. Okay, now see how this nut moves up and down? It's constrained. We're good. So now flip your gear over so we can see it. And press mate. And press the side of the gear and any side of that hex hole. Now see how it's spun around and auto-aligned? Hopefully. Want to see it again? So I do mate, side of the hex, side of the hole, and it spins around. Now, see how this says coincident? Very dangerous. Anybody know why? For 3D printed objects, we have tolerances. This hole, this hex is 5.5 millimeters. Now I happen to know that a 5.5 millimeter hole will be just perfect. But if for some reason I used a different surface finish and I had to have a 5 millimeter hole or a 4.6 millimeter hole instead, it would not do coincident because they couldn't be on top of each other. You don't want that. You want parallel. That's safer. That allows you to adjust the tolerances of the hole without actually hurting your mate. Now press the check mark. And again, drag your nut around and see that we've further constrained it. It can no longer spin about that axis. Now the last step, select that bottom of the hex hole and then select the bottom of the nut. And it moves right into place, hit the green check mark, and that assembly is done. And just save it.
So there's no way to like press it. It's not like in reality you're going to be clamping it and pressing it, but in SolidWorks there's
No. There are no slip fits or press fits or interference fits in SolidWorks. There's only sizes and geometry.
Ruben, have you ever tried to get the screw redstone line? Does that matter?
My guess is that will be disastrous.
You could maybe do it for like, maybe with parallel group concepts.
Not sure. You always want to just play it safe with SolidWorks, just so as to not screw oneself. Okay. Does everyone have this assembly now? I don't mind going over parts of it again. Just let me know. Join us or you?
I got 2 screws instead of both screws, so I don't know.
It's fine. Right? Just save your assembly and we can use that. Yep.
when I'm trying to save the assembly, it's asking me if I want to save the screw.
Yes. Things downloaded from McMaster,
Yeah.
they're always an older version. So what happens is SolidWorks does not make, backward compatible. So if you have 2009 SolidWorks, you cannot open 2011 SolidWorks. And so what it's saying is hey, that screw is like 2009 SolidWorks. When you save it, you're going to convert it to 2011, and then you'll never be able to open that on a 2009 machine again. That's fine. Just hit yes. Okay, does everyone have something in their assembly? Okay, so I've been getting a lot of questions about this one gusset. So let's do that gusset. Basically, we're not here to learn about parts tonight, but we have to have something to assemble. And this part has been hurting people, so let's do that real quick. Everybody do File, New, Part. Then I want you to press Extruded Boss Base and select the front plane. It doesn't matter which plane you select, but I'm just selecting the front, and yours should look like mine. Okay, now take a line and make a horizontal line. Then do an angle up here. You see how it snaps to the vertical? Let it snap, and then draw down to the corner and hit escape. That's the rough shape, right? Everybody have a triangle? What's up?
Oh no, I did it like really different.
It's okay. There are many roads to Rome. Rome being our gusset. I'm going to show you my favorite way of doing it. You're free to do it. Huh? This is the gusset. This is CS235 gearbox gusset MDF2. I considered putting a lot of dashes after that just to try to get past 30 characters, but I didn't. Have you done that one? Okay, so you can either do it my way for fun, or you can just use your part. Okay, so everybody have a triangle? Trudy, you might want to follow along. I'm going to show you some things that I'm guessing you haven't seen. Triangle? We good? Okay, so let's just go ahead and dimension the overall thing. Do smart dimension. The bottom is 150, and then the side is 100. Yeah, everything's millimeters. See how it's black now? So we're fully constrained. It's beautiful. Okay, now there's some new trickery going on here. So I want you to, around here on my screen, see how this is about a quarter of the way through? Draw a vertical line, and then we're going to make just the rough shape. Now I'm intentionally drawing this poorly, and I want everyone's eyes on my screen for a sec. This does not look equal, does it? Okay, this is how you make your life easy in SolidWorks. Keep watching me. I select this line and I press collinear. Boom. Awesome. So now we can drag this around. but you see how this distance here is longer than this distance? Press this line, and press equal. Boom! So this is the trick, and I forgot to mention this in the original training. Collinear and equal I use more than any single other thing in sketches when I have lines. Now watch when I drag this around, it's the right shape even though it's not the right size. And that's fine. So now do smart dimension, and then let's see, this is 30, and this is 19.05. Okay, so now it's the right size, it's the right shape, but it's not in the right location, is it? Oh, and then this dimension here is, sorry, the way I dimension this is 10. Okay? So, it's the right size and shape, just in the wrong location. So press this top bar up here, and this bar here, and what should we press to get them to line up? Anybody? Collinear. Boom. And then the last dimension it looks like we're missing is this big one here is 40. And then now it turns black. Okay, does everyone's screen look like this?
You did your line with the edge.
Here, let me. Okay, who's having issues? No, stop doing that, Ruben, stop.
I take control and do these two.
No, that's a dimension line. See how it's thinner? Select the thick line, and that one,
yeah,
and now press collinear. Collinear lines the two lines on top of you. Can I see for a sec?
Yeah, on the right, on the left.
Okay. Now, go ahead and dimension that one to 40. Yeah. So you can either select the points or you can select the line. It's one less click if you do the line. And then select that line is 30.
This one should be 40. Oh,
Okay. Now hit escape. Drag that line down until it's the right geometry again. Okay, cool. Now dimension that line to be 19.05.
This one?
But you first you have to select the smart dimension. What's up?
Somehow, after I did the pairing, it just jumped up.
So what you do, it did that because it's unconstrained, because it's blue. So you click this. Oh god, it looks like we.
Should I exit?
Okay. So let's see where we are. You're good. All right. So click that line, hit Control, and that line, and then press collinear. Now you're good.
Sorry.
What's up?
Do you know, I'm missing, I think.
Yeah, dimension that line, the little one, to be 10.
Ah, I see. But the little ones are the ones that are actually equal, right, on the two sides?
Yeah. So yeah, if you're diminishing lines, it's best not to click on individual points. Click just on the line. Michelle, are you good?
Yeah.
Okay.
I'm just having these two little. Yeah, I mean, there are multiple ways to fix it, but what's a good way?
What are you trying to do?
These two are so blue.
Oh, dimension this little black line to be 10.
Okay. But you do have. All right.
Good. John, you doing okay?
Yeah, I'm doing it.
Okay.
What's the last constraint to
Oh, that little line should be 10.
this one?
Okay, I believe everyone. Okay, select the little line, and then select the other little line. Are they actually? Can I see for a sec? So you're not zoomed in far enough. It's a little hard to see. Oh, I see. Okay. So click on that line, and then click on that line with Control, and then over here press collinear. Okay.
Why is undefined area?
Because you never defined how far to the left or right it was. Collinear's setting that for you. Is everybody good? Okay. Now press the purple check mark. Okay. You see how it didn't turn yellow? It's angry. We're experiencing the wrath of SolidWorks. And if I hit check mark, it says the sketch has both open and closed contours. Okay. So I hit X, fine. I go back normal. Does anyone know what's wrong with this picture? That right there. Does anyone know how to get rid of that? Power trim, yeah. So this right here, trim entities. And now don't do power trim. Do trim to closest. This bottom one. And then press there and it goes away. And now it kicked me out of my sketch. So I have to do sketch, extrude base, and then do 19.05. Then we're good.
What is the trim thing?
Where did you find it?
Let me show you. Okay, look at my screen right here. Trim, and then pick the bottom one, trim to closest.
What does it do?
It cuts. So select trim to closest,
Yeah.
and now put it over this section right here, and see how it'll turn red for you. Click on that line, and that line will get deleted. It will trim the line. Okay? So now I want to make sure everyone's actually extruded properly now. So we should all have a triangle with one little wedge. We all good? Is everybody extrude?
Do we have the dimensional issue?
Do we have what?
Is there a dimensional issue?
19.05. Okay, so go back into your sketch. We need 4 more of these. So I'm going to show you 2 ways of doing this. One is laborious, the other is not, but it's very dangerous. So first, go ahead and draw that rough sketch here. Now let me show you something. Eyes on my screen for a sec. When I click this down, you see how it wants to auto-align? That's usually not a good idea. SolidWorks does dumb stuff. You usually, if I get in this scenario where it wants to auto-align, I intentionally come up or down until it doesn't auto-align. Do the rough shape again. See that? That was a mistake because it tried to auto-align me to something. It's going to screw me. So come up like this. So I've got the same shape again. Now, I could do the same thing again where I do equal and everything, but I don't want to drive this one off of itself. I want the same dimensions as this other. So watch this. I click this line, and the one with the 10 on it, and I press equal. I select this line, and the one with 19.05, and I press equal. Then I press this line and the 30 millimeter one, and I press equal. And the final thing I'm going to do, so let's just stop there for a sec. Did everyone do that? And do you see why I'm doing this? Yes. And in the end, we will do that. There are many ways to make this part. Some of them will be very laborious to edit. Some of them will be painless.
I did it so good.
It's okay. I sort of forget because I've been doing this for years that it's actually quite a pain in the butt. So let me know when basically you're ready to go if the only place, well, nope, that didn't constrain. Why didn't that constrain? Okay, so basically you should be able to pick a point on this and slide it left and right, and then you know you're good. If that's all it's willing to do, that means we're good. Is everybody there? Would anyone like to see me do it again?
I tried to do the equal trick and it destroys the previous equal.
If you press the wrong lines and press equal, it gets very grouchy.
So I equal that one, and that one.
Yes.
And previous I've made that one, and that one equal.
Yes.
Now these ones are shorter.
Can I see? That's because I think somehow it didn't quite take. Can I see? equal, equal, equal. Good.
Yes, I did.
Okay.
I generally did that for that one.
So now this one, and this one equal.
Does it matter that you took that one and not that one?
No, because they're all set equal. It's one of these commutative, I think, is it commutative laws where A equals B equals C, and then you can put C in the middle, and
Yeah, but so there was no reason you picked that one.
yeah, it doesn't matter. Okay.
So not this one and this one.
Yeah, and then you're done. Is everybody good? Can everyone slide their little thing left and right? Okay. So, remember how we did the collinear trick to line it up? There's a version of that for a line and a point instead. So on the right, eyes on my screen, you see this point here? This is all we got to work with in terms of lining it up. There are two ways we could go. We could either put a center line here, and then we could use the collinear trick between this and this, but that's sort of a pain. Click this point, click this line, and hit coincident. Boom! The point doesn't actually have to physically be on the line segment, just on the theoretical line through that point. Did everybody's on line? Just so you know, this is one of those things where it may, if you didn't do it perfectly, it's going to complain bitterly.
Alright, are we extruding?
Not yet. Because we still have this line here that we need to get rid of. Hit trim, get rid of that little segment there, and now go ahead and hit the purple check mark and make sure it still extrudes, and then save as whatever you want.
For the actual lab, is this the gusset part 2?
Yep. And I'm perfectly happy to have you all turn in the parts you generate tonight. That's legitimate. The reason I'm doing this tonight is to help you with homework. I learned from tutorials and it was painful, like online tutorials. Yep.
So when I was doing it before, I sort of, like I did the triangle first,
Yep.
and I added these things later.
Yes.
In that case, like there was no trim or anything, just sort of added it in there.
Perfectly fine.
Okay.
Yeah. Mainly I'm showing you this because it teaches you some of the cool constraints. And the ones I'm showing you are the most complicated you want to do. If you start getting much more complicated, it's going to blow up. So has everybody got extruded with two little thingies? You good?
What size?
What do you mean what size?
Extrude.
Oh, 19.05. Anyone know what that is in inches? 3/4. Eighth is 3.175, quarter 6.35.
It says that it's gonna pre-build a feature.
Did you trim the little segment?
Oh, good.
John, are you good? By the way, do you go by Jonathan or John?
John?
John? Okay. Everybody else good?
And we do line extrude.
Yeah. Okay. So now that you're extruded, go back and edit the sketch, and we're going to add the last two. So, actually first, just so we can see why we did the equal, change that 30 to a 10, and watch that both change. Change the 40 to a 45, they both change. That's why we did it. Because that is the safe way of doing it. We can modify things willy-nilly and everything updates. Okay, so we're going to add a third one, and then I'm going to show you something cool. So let's do the third one up here. So do the rough shape again. You guys are going to be experts at clicking by the end of tonight. And then we're going to do the exact same constraints and base them off of the dimensioned one. So this line, and this one, 19.05 equal. This line, and this one, 10 equal. This one and this one equal. And then I want you to press the top vertex and this line and press coincident. And everything should be black, and then trim away that little section that we had.
Does it matter the order in which you apply the constraints? I mean,
Nope, it does not. Yep.
Did you put them equal to the wedge down here?
Yeah.
Okay, that's how I got them.
It actually doesn't matter You could set them equal to the other wedge. As long as you never delete any of the wedges, you're fine. You only get into issues if you start referencing things that are referencing things that are referencing other things, because if you delete anything in that chain of references, you're screwed.
How do you get back to the editing? Now it creates another sketch too.
Press X and accept cancels.
So I cancel extrude. Or can
Yeah.
I go back and...
Yeah, discard changes and exit. Okay, select boss, right click, edit sketch.
This one? Or?
Doesn't matter which one. The top left corner, the blue one. There you go. Does anybody need... How can you what?
Delete a point.
You can't. You can delete a line though.
Oh, okay.
And
No.
you want to zoom in more. You're too zoomed out. It's hard to see. Okay. Uh-huh.
Numbers, like, basically the actions that you did, the numbers that you see over there.
Oh, 24, 20, 25, 22. Those are the numbers of relationships. And if you click on one of the relationships, you can delete it if you wanted to. So, say, and also see how when I scroll over it, it turns the things purple that the relationship is. So if I selected 25 and hit delete, then I suddenly no longer have that relationship, see? Okay, does everybody have a third wedge? Once you have your third wedge, I want you to re-extrude it so we can make sure it's working. Often if you're doing a complicated sketch, it's good to basically, once you've done a little section of the complicated sketch, you just extrude it to make sure there are no issues, and then save it and then go back in, because trying to debug what relationship went wrong out of 1,000 little clicks is really hard. So let me know when everyone's got this on their screen. The next thing takes only 4 clicks to get you the 4th one, so it's cool. We good? Okay, so go back and edit that sketch. Now watch my screen for a sec, please. Okay, so I'm going to take a construction line and put it in the middle of this line. You see that? How it snaps to? Except that that's not what I want. What I want to do is I want to take this and mirror it about the center of this image, about the center of that 100 thing. So what I'm going to do is I'm going to take a construction line and put one end at the top and one end here. Then I'm going to take another construction line and place it here like this. See? Now it's not in the middle. That's fine. You press on the end of that and on that construction line, and you press midpoint. And now it's in the middle. Now this is the magic. You click left here and select all those lines and hit Control until you've got that entire thing. Click this line, and then up here this button, mirror. Boom! The only thing I have to do is trim that little section there. And then I can re-extrude and I'm done. This normally works really well in sketches. Often backfires in assemblies. The exact same thing works in assemblies for, like, say you've got a screw on one side and you want to mirror it to the next. I don't know why, but the Solidworks monkeys have decided that they should not invest debugging time on that. So half the time your things are upside down and twisted and deleted. But sketches, it's really pretty reliable. Does anyone need to see me do that again? Okay.
What about for parts? Like if you already had a solid extrude and then you want to kind of mirror it about another axis.
That works most of the time.
Okay.
Okay, so does everyone, all right, start from here. Take a construction line,
Construction line is same as the center line.
Center line. Okay. Press one in here on the top corner and one down here on the bottom corner. Okay. Press escape. Now take another center line and put it somewhere around here. Okay. Everybody got those two lines? Then you press this point here, hit Control, and select this line here. And everyone see on my screen down here it says midpoint? Press midpoint. So now we have a line in the center. Now, holding down Control, you click all of these lines here that we want to mirror. And it's best to click them one by one so we don't get anything we're not expecting. Then click that line about which we want to mirror and press the Mirror Entities button. And then the only thing left to do is to hit Trim to get rid of that little thing. Then exit the sketch and hit Save. So you see, we actually could have done that twice, and then we only would have had to make two little nubbins and then mirror two of them. How you doing? Yeah, trim that and you're done. Michelle, how you doing?
I'm good. I'm following along.
Okay.
So we could have done that on the bottom.
Yeah, could have done that on the bottom. I just wanted to show you how to do the collinear stuff. John, how you doing?
I missed selected for the mirror thing. So how do you select? How do you indicate like subject and object? Like how do you like separate the two groups of selects?
Have you made your center line?
Yeah, it's all good. I just have
Okay.
to mirror, how do I like? So this is like subject set and object set. I guess, right?
Press mirror. Like press in here.
Okay.
See, okay.
Oh, cool. And then just like.
Then press that and you're done.
Cool.
And then trim that little section. Okay, re-extrude. Done. There are two gussets in Lab 1. They are identical parts, except the one we're working on has two holes. So, open question. Would you start by making one part before the other? Or would you just make two separate parts? If you make one part, you can save a copy, and you have the second part for free. Then all you have to do is delete one of the holes and you're done. A lot of the time that I have to do a lot of parts that are really similar, I make all of the common elements and then save a bunch of copies and then just add the unique aspects of each copy. Michelle, would you like me to help you?
So I made the part a different way, but so I'm following.
Okay.
But I haven't
Good.
copied anything.
Okay.
Technically, we're making the two.
Yes, we're making a pair. Okay, everybody go back and edit your sketch. The only last thing we're going to do is add two circular holes. So take a circle and just make two of them. Okay? Here's another trick. So smart dimension one of them to 22.6. And I want them to be the same diameter. So select both circles, hit Control, and press equal. They're now equal. The bottom right hand one is dimensioned as 80 from the left hand side. It's dimensioned as 17 from the bottom. And then this left hand one is 19.675 from the left. And then it is 28.25 from the bottom. Oh, 21.6, sorry. Your bearing would have fallen out. Let me know when everybody's got those holes.
Where does the 21.6 actually no, the 28.25 come?
As in, why did I pick that number?
I know, like what?
Oh, from this bottom line here to that circle.
I see.
Okay, have you?
Mm-hmm.
the center of the circle?
You can either click the center of the circle or the circumference. It doesn't matter which. Oftentimes, it's 21.6. Anyone know why? What's up?
So what was the distance between?
Oh, so you press this, hit Control,
It's the other control.
and this. Oh,
The one.
okay. And that point, coincident. Okay. Now you hit trim, and you trim that. Okay. Now take a construction line.
So the positioning of this,
Uh huh.
how do I do that?
Okay. Press on the outside of the circle, and press on that bottom line.
This one?
Yep.
Oh, then you go from.
Drag that way.
Ah.
Okay. And that one is 28.25. Okay. From the top point to the bottom point.
28.5?
But you don't have any line selected yet.
Oh.
20.
Not 17?
No. Wait. Yes, 17. Sorry. Now do the same thing for that one, and that one is 28.25. Nah, here. Can you see?
Okay.
So for some reason you're not selecting the line. Okay. If you have a line,
Oh, my mouse doesn't change.
oh, that's weird. Okay. There to there.
Okay.
You good?
On this last one,
The last one is 28 point.
19.6.
And then from the center of the line.
And then the second line, click somewhere in here along the up a little bit. That's fine. Yeah, and then drag right.
Are the radius the same?
Yeah. So the way you do that is click both circles.
Yeah. Like that?
No. Hit escape.
Just click them.
Click both of them with control.
Oh, what do you do? Is it cut?
And then press equal. What's up?
Oh, and then?
Okay. Now press on the end of that line and hit control and press on the second construction line up a little bit. No?
Oh, this one.
There has to be a line there.
Yeah.
I don't think you have a line on your screen. I don't see it. Is this a Mac? Yeah.
Maybe it's.
Can I see it for a second?
Yeah.
I don't. That's really weird. Alright, I think it did it there. Okay. Whoa, what's going on? Whoa. Dude, I don't know. That's really weird. Alright, let's do it a slightly different way for you. Something's not right. You should be able to see the line. What the hell? Fuck it. I can't see your line. Just dimension this. That's 50. That's fine. Okay. Now click on all of these lines and then click on that line and press the mirror button. Okay. Is everyone? Oh, good. And then click on this line too.
That with control?
Yep. Every time you guys select multiple lines, you have to hold down control. The mirror is right there. Okay. Interesting tidbit. Yours is not fully constrained. Can I see?
Yeah, why are these keeping being blue?
Hit control. Hit control.
So if they are blue, that means they are not constrained?
Yeah, I'm not sure. Let's figure that out later. And then the only thing you have to do is trim right there.
Yeah.
And then you're good. Okay, so everybody got 2 holes? Just a quick aside. You know how I told you to select all the solid lines you want to mirror and the dash line and then hit mirror? If you select more than one dashed line, it will barf. It's fine, and it'll ask you, hey, which one of these dashed lines is mirrored? You can only mirror about a dashed line in Sketch, so that's fine. The other way you can do it is only select the solid lines you want to mirror, then press mirror, and it will have a little spot where it says what are we mirroring about. Put your mouse in there, and then select the axis, and then you're done. Okay, so we're good. So the last two steps are, we could, you know those little circles at the corners of everything? We could have sketched those in the same sketch. I can tell you from experience that's a pain in the ass. You have to trim everywhere. So here's the thing. When you trim a line that has a constraint on it, it deletes the constraint. Often. Not always, but often. And it's non-deterministic, and often enough it's very irritating. When you have constrained lines, try not to screw with them later on. So if you have equal lines and collinear lines, try not to mess with them. Don't trim them. So what I'm going to do is I'm going to do a cut. So I select this face, extruded cut, and then I take my little circle, and let's see where I put these. Basically every corner. Now you see how I snap to? So just start putting them everywhere where it wants to snap to. Like that. And notice that I am doing this quickly without care for how big they are. Anyone know why? I'm going to equal constrain them in just a tiny bit. So go ahead and put circles at all of these places. Does anyone know why I'm even putting these circles for the physical part? When you fit these parts together, mathematically for them to fit, they have to be perfectly 90 degrees with no radius. The laser cutter has a radius of 0.005 of an inch, which is just enough to make sure that it does not assemble properly and your gears don't assemble properly. By putting these little circles, we're getting rid of that radius. It's called an undercut. So then we're guaranteed no material will ever overlap. So once you have all of your circles, watch this, left click and select all of them at once. That keeps you from having to click all of them. Do this, and then press equal, and then just smart dimension it, and I believe it's 2 millimeter diameter. Then just press the purple check mark, and then I'm going to show you guys something else interesting. If you're making a cut that always has to go through the entire part no matter what, you don't want to do blind. Because if you change the thickness, then you'll have to change the cut thickness. Select through all. Now, no matter how thick we make the part, it will always guaranteed go all the way through. See how easy that was?
They go through, what was that?
So right here, through all instead of blind. So again, now if I redimension this and I make it 50 millimeters long, it will still go all the way through, even though originally it was 19.05. Has everyone got circles? Cool. One last thing. We need chamfers. Again, chamfers in drawings equals pain in the ass. Insert, features, chamfer, and now just select the edges that you wish to chamfer, and I believe I set these equal to 1 millimeter.
You said the straight distance is 1, so should you do 1.14?
I believe it's referring to the straight distance. Chamfers are weird in terms of how they're dimensioned. I don't particularly remember. I think if you just set it equal to 1, you'll be fine. I also don't particularly care because we're just basic. Does anyone know why I'm doing this chamfers? Soft materials get dinged really easily. If you give a thin, sharp corner, it will ding and then you can never assemble it because it's in the way. So all I'm trying to do is get rid of the razor's edge so that I can assemble this thing cleanly. Then you just hit the check mark. Boom, we got chamfers. We're done. So that is one of the parts for Lab 1. Is everybody good with that? Has everyone chamfered and put their circles?
Chamfered.
What's the dimension on the circles?
A radius of 1 or a diameter of 2.
You mean the circles, the edges?
Hmm?
The edges?
Yeah, just the edges. And then change that to 1 millimeter.
This one?
Mm-hmm. Yeah, and just select the edges from that you see in my screen.
Highest diameter, right?
Huh?
Highest diameter, right? And you remove the copy?
Yeah. Nice. Good.
Did you pick all of them?
Just the inside ones. I mean, here's the thing. If it's something that's important and you didn't do it and you turn it in, I will tell you why it's not important and maybe I'll take a point or two off. If it's something that's not important, I will charge you for not following instructions. I will tell you why it's not important, and I probably won't take points off because that doesn't matter. Chamfers, as long as you have them in the right spot, I really don't care what size they are. Mm-hmm.
Ruben, you're going to post this video online.
Mm-hmm. How's 218C treating you?
I don't know if the class is worth it.
It's worth it.
I hope so.
You really know your stuff by the end of it.
Did you want to mention each other?
1 millimeter. Be of good heart. Be of good heart.
Oh, yeah.
The summer will give you a little break.
I hope so.
Okay, so let's make an assembly. Press File, New, Assembly. Okay. Take that gusset that you just made. Insert it here. Float it. And I'm not going to proceed until everyone has a gusset that's floating around their screen like a ghoul. Huh? Oh, okay. You okay, Jonas?
Yeah.
If you're in the middle of like a 25-step select,
Yep.
and then you just click and lose it, can you get it back? Is it gonna do like Photoshop?
I don't think so. It's a subject of much consternation. Okay, we're running out of time. Everybody should have, even if you don't have chamfers, that's okay. Let's everybody put a gusset in here. Throw it on. And actually, okay, show of hands. Who's got gussets? Go ahead and make a new assembly and stuff that gusset in here. It doesn't have to be finished, but it's getting late and I want to make sure we go through the rest of the mates. Okay, so go ahead and align all the planes again, front with front. God, I hate this. Okay. Okay. Top with top, and then right with right. Cool. Save that as something. Mine's called RTED, RTE, RT, RT, ERT. Then I want you to insert one of those little gear assemblies that we made. Now this isn't, at this point we're now officially departing from what we're doing for Lab 1 because we just don't have enough of the actual part to do the proper assemblies. I just want to show you the mates. So everyone now should have a gear assembly and a gusset in a new assembly, and go ahead and save that.
Just insert component.
Yeah. Mm-hmm.
So an assembly also becomes a component.
Yes. So an assembly can have either parts or sub-assemblies within it. It's like Russian nesting dolls. It's an assembly within an assembly within an assembly, which is perfectly fine. I think I've gone like 10 levels deep at some point, and so let me know when everybody's got a gear in there. Do you need some help, Niels?
No, okay.
Okay, we good? So let's align this gear and let's just pretend there's already a bearing there, and there's not, but that's fine. Go ahead and insert component. Oh, sorry, scratch that. Mate, Click the surface of one of the holes. Click the inner bore of your gear. Perfect. See how it aligns concentric automatically? Hit the green check mark. Then press the surface here and press the surface here on the gear, and it's coincident. Let me know once everyone's done that. See you, Alice. Yep.
So when I put in the gear assembly,
Yep.
it's fixed and I can't seem to find the float line for it. Like,
Is it the first thing you put in the assembly? Okay, right click just the assembly like this. Is there a float there?
oh wait, sorry, I was looking at the visual view instead of the list view.
Yeah, the list view is usually better. It,
Fix the back of the gear to the front of the gusset.
yeah. This is just purely just an example now. This actually isn't in the lab, but we needed something to assemble with something else. Does everybody have a gear that's mated to the surface of a gusset?
Put the wrong side.
Okay, real quick, everybody eyes on the screen. Say you screwed up a mate, which I do quite a bit. See this little button down here? This shows you every mate in that entire assembly. You can select a mate you don't like, and you can delete it. Okay? Now the other thing I can do is I can go in here and in the list, right click, you see this mate? That tells me every single mate only for that subassembly, or only for that part. So say I decided I don't want that to be coincident, and say it's a really big assembly and I can't figure out which mate it is from this list. If I click on the assembly and I right click and I hit mate, I can pull up the mate that happened there and I can hit delete. Now, just a quick note, why is this dangerous and why do you have to do it in the left? You always want, it's an assembly level mate. It's we didn't mate with this gear, we mated with the assembly that contains this gear. If you click this gear and hit view mate, it'll show you stuff, possibly, within that subassembly. And then if you start deleting that, you really get screwed fast. Never right click a subassembly and look at mates and delete. Always go to this list, make sure you have the actual assembly, and then view the mates. Okay? Let me show you again. I click here, I say view mates, see all of this crap? All of the stuff down here, those are all mates from that subassembly. Don't touch them. You always want to go over here to the left, select the assembly, then view mates. Now see there's nothing here. It doesn't show me the part mates. So real quick, I'm just going to do it with you again. Go ahead and put a coincident between this hole and this bore, and then a coincident between this surface and the back of the gear. Does everybody have that? Jonas, you doing okay?
Yeah, it's good.
Huh? Yeah, it is. Actually, so I'll show you another day. There's actually a gear function where you can specify gear ratio, and then when you spin one gear, it spins the other. So it's not angularly aligned, so it's not like the teeth mesh properly, but it's pretty cool. Okay, everybody select a second gusset, or sorry, insert a second gusset. Again, this is not for the homework, this is just because I need something to show you guys with. If you have planar stuff, okay, and just watch me for a sec. Mate, I don't know, just for fun, mate the bottom of this to this. Mate this surface here. And then mate this surface here. I just want to show you how you mate plane, like flat surfaces. So that's fully constrained. The last thing I'm going to show you is sometimes you need to do a tangent. So You know what? No, we're going to save that. At this point, I think do you guys all feel comfortable inserting components and putting some basic mates on them? Let's go ahead and do a drawing so then anyone who needs to go can go. So, there are two ways to do a drawing. So a drawing, real quick, let everybody hit File, New, select the drawing button, and hit OK. It's going to have a pop-up. Don't answer it yet. You see the display sheet format thing? You see in the preview all this crap here, all the text and the tables? We don't want that. That's for people at Lockheed Martin. Don't do it. It's bad. It's like version control and who signed it. Press that display sheet format and it will go away. Now, there are some defaults here. A is pretty nice. Does anyone know what 279.4 millimeters by 215.9 millimeters is?
8.
It's 8.5 by 11. So if you make that drawing and you print a PDF and you email it to me, I can print it out on my printer and we can talk about it. Awesome. However, we're laser cutting stuff and we have a 4-foot laser cutter. So if you send me an 8.5 by 11, it's going to look very strange to me. I will not accept that because I won't be able to visually tell if you've put it in the right orientation. So I can just tell you, because I've done this a bunch, 48 inches safely is 12 19 millimeters by 12 19 millimeters. So custom, width and height are both 12 19 millimeters, and hit OK. Everybody should now have this screen. Go ahead and do, man, my SolidWorks is freaking out. Do Insert, Drawing View, Model. I'll leave it up on my screen here. This is how you insert a new part into the drawing. Insert, Drawing View, Model. And I want you to select that gusset. Now, move your mouse into the middle of the screen and you'll see it's got kind of like a blank box. See that? Everybody should be wiggling a blank box. That's incredibly frustrating because there are many different views that I could have. I could have isometric at an angle. I could have orthographic at different faces. So what you do, see over here, there's a preview. Press the preview button and now it shows me what it wants to draw. Okay? So now it's easier. Now see these different buttons? Press a different button and watch how it switches to a different angle. So I want you to select the one that looks like this. Just press the button until you get it right. Okay, now, if you're making like the drawings I made a couple nights ago for you guys just to show dimensions, you want it to be reasonably sized for the page so it's not too small, it's not too big. For the laser cutter, it cuts 1-to-1. If you send me something with a weird scale, I'm going to cut it like that and then we're all going to be upset. So go down here and you see this scale here. Never ever ever use sheet scale. Always do use custom scale and set it 1-to-1 for laser cutting. So what this does now, and then finally put your drawing in the lower left hand corner, hit click, and then just to show you something, when you click, you see how if you move your mouse it gives you other views? Like these. I can keep clicking. I can put all these other views. Those are called projected views. So the first one we put is our main view, and the others are what it would look like if we then moved it to different angles. I don't need those, but you guys need to know that that exists, because if you're dimensioning something, then you know that's the story. So go ahead and give me those projected views just to practice it for now, and we'll delete them later.
How do you get them moving across? How do you move them?
Oh, yeah. It's kind of irritating in SolidWorks. You cannot just click on it. You see how the box appears? Usually if you click on the outside of the box, it'll let you move. Okay, does everyone have these 3 orthographic views? Or 2 orthographic, 1 isometric? Okay. Now, zoom out That big gray square is our laser cutter bed. The bottom left-hand corner is how it will look on our laser cutter bed, exactly 1-to-1. That's perfect. That means if you guys give me something that doesn't fit on the bed, I can tell immediately that the scale is wrong. So let's pretend for a second that you're giving me a dimension drawing just for reference and we're not laser cutting. Go ahead, select this view and delete it. It'll ask if you want to, yes. And delete this one too. And we're just going to be left with these two. If we're going to do a dimension drawing, you can do Smart Dimension just the same as anything else. Smart Dimension just shows the dimension. So press Smart Dimension and press this line here, and that shows that this is 19.05 millimeters. Terrific. Okay? Now you see here in these circles, see these crosshairs? If you're giving me a dimensioned view like the one I gave you for homework, you want to leave those in. And you want to dimension from them. So you can click the crosshairs, click here, and it gives you dimension. Click the crosshairs, click here, it gives you dimension. Here's the thing. If at this point on my screen I were to save this and send it to the laser cutter, it would literally cut a giant arrow and 80 and the crosshairs and ruin the parts. Anything that is on your screen when you click save to send me for the laser cutter, it will cut. So now let's pretend we're laser cutting. Here's the way that you get rid of all crosshairs. Select the entire screen. You see how it selected all the dimensions, and press delete. Notice it does not delete your views. So to show you again, I select everything and I hit delete, and it did not select my views.
If you're on a Mac, maybe you could use an option in backspace or something.
How do you what? You can right click the screen. So yeah, select left and then see how they're both selected. Press the right click of your mouse and it gives you the option to delete. Okay, please go ahead and delete this second orthographic view. Yep.
If your orthographic view is not the same as mine.
That's because you started your extrude on a different plane, which is totally fine. So that just means you're going to have to select a different button from what I select to get the same eyeball view.
The problem with the right click delete is that it, at least in the Solidworks, like removes the group select. So I can only delete one at a time.
Did you try holding Control down while you right clicked?
Yeah.
Did you try backspace?
Yeah.
Well, my friend, you may want to buy yourself a cheap USB keyboard. So any issues you're having right now with these parts and assemblies are going to be 100 times worse by the end of the quarter in terms of annoyance. If you're having any issues whatsoever, they're not dumb issues. I think you're all doing really, really well. But if you're having issues, let me know. And it probably is going to be solved by getting a wireless keyboard and mouse. I mean, there's just no way around missing a delete button. If you don't have a delete button, you don't have it. So the only solution, based on SolidWorks being crappy software, is to buy a new keyboard. Okay, so I'm going to show you something real quick. So we're laser cutting this on wood. Wood costs money and trees, and we'd like to save both. So say I'm going to insert another. I'm going to do insert, drawing view, model, same gusset. See how it's way bigger? That's because it's the wrong scale. Go down here, custom scale, 1-to-1, and I put it here. Great. Now, what's wrong with this picture? Couple things. Crosshairs and too much space. So I delete the crosshairs. Now I could put this here, but is there a more compact way of fitting these two things together? Yeah. So what you do, and I literally, I only learned this, I've been doing this like 6 years and I only learned it last week. Select this drawing view and see this button right here? Rotate. Select, I don't know, is that 180? 180. Apply. Booyah! And now we move it down and we go here. And now we're wasting basically no wood whatsoever. So, everybody go into your starter file real quick. Let's see. Go into your starter folder with all the stuff for homework 1. and you see, let's see, CS235 Gear Lab 3/4 MDF laser layout.pdf, you're going to send me 2 laser cutter files that I'm going to cut for you. They have to look like this. If they don't look like this, I'm not going to cut it. This shows you exactly how to lay out the parts. There's also one for plywood, just like that. Now I may have screwed up the size. It may not be 1219 by 1219, but as long as you guys have, so I need 3 things for a couple things from laser cutter files. I need the size to be 1219 by 1219. I need everything to be in the lower left-hand corner. I need it to be set up in terms of where the parts are, exactly as mine is. And I need all the crosshairs and all the text and all the dimensions to be gone. As long as you got that, we're good to go. Now, there's one last thing. Everybody go to your drawing and hit save that, okay? As whatever you want. And notice it's saving as a .drw/SLD-DRW. That's a Solidworks drawing. That's fine. That's how you save drawings. And now, coincidentally, just to show you real quick, everybody on my screen, I'm going to go back into that gusset real quick and say I decided I don't like this hole, so I turn it to a construction. Okay, now I go back into my drawing and magically it's updated. Just to make sure, save all. Now I can't laser cut a drawing file. This just doesn't work. I have to have a DXF file. I also have to have it metric and 1:1. So go here, SolidWorks File, Save As, and then Save As Type DXF. Here's the thing, there are literally like 30,000 different formats of DXF. So I don't expect most people to get this right in the first try because I don't know what the settings are. Basically, if I can't open your file, we're going to twiddle around with your laptop. So when you come to get your stuff laser cut, bring your laptop with SolidWorks and your mouse because we're probably going to be screwing around with the DXF file format until it works. But if you need to do that, you're going to do this, come in here, and you'll probably be changing the version. I think it's like R13 or something, but I don't remember. For now, don't worry about it. Just know that I can't cut a drawing, so you go File, Save As, File Type, DXF, Save, and we're done. So real quick, let's review what I need to be able to cut your guys' laser cutter files. Can anyone list them for me? Give me 1 second, let me write this down. I don't mean to, we do a lot of cutting for other labs, and this is why every time someone wants to cut for 5 minutes, it takes 5 hours because they don't do this right. So, what's the size of your file? Millimeters. Okay. What's the scale of every single view in your drawing? Why is that? Yep. Okay. What file format is it? DXF something. And then what about any lines or anything? No construction lines. And then finally, oriented like mine, and that includes lower left corner. As long as you guys have all that, it'll be perfectly fine. And I expect that, we'll have issues with the designs, etc. So I don't mind recutting, but if we do this every time, at least we won't be making any just file formatting issues. Okay, so let me review and make sure we've got everything. We've all made simple parts, planar and non-planar. We've made a drawing. I've gone over how we're going to format for laser cutting. We've made a simple assembly. I gave you all the starter CAD, including dimensions. Is there anything that do you have any burning questions for stuff? Yep.
Is there a minimum distance?
Not to my knowledge. We've cut tiny, tiny stuff. I mean, just ridiculously tiny stuff.
But you can't literally put one line
No. Well, you can't. People do that in the PRL because they get lazy and they don't want to do it, but that's not a good idea.
The laser just removes some of the stuff, right?
Yeah. So show you guys a quick trick. Say this is a circle I'm going to laser cut. It's going to drill somewhere, and it's going to draw a circle. And say this is my bearing hole, 21.6 millimeters. What size is my bearing outer diameter? 22. Okay? So why would I make this 21.6 millimeters? My laser is a circle. So I take this circle and I move all the way around, and now I have 22 millimeters. This we just have measured empirically. I suppose that's 0.4 millimeters? Maybe? No? 0.2? 0.2. Now we can select and we can change stuff on the laser cutter, but you guys don't worry about it. This is black box for you. The reason why we do this is in plywood and 3/4 MDF, if you make your holes D minus 0.4 millimeters, it will be perfect, spot on, press fit worthy or slip fit worthy, whichever you want. But that's the reason why we're doing that. So in all the gears I gave you, it seems like really weird diameters, right? Let's just take this one. I have 3 little holes for dowels, and these are 2.6 millimeters. What size dowels am I using? 3 millimeter. So after I cut this, it will be 3 millimeters. So that goes to 3 for dowels. Okay? Then I believe, depending on the part, I did 1, 2, 3, and I made this, on one of them I made it 2.1 millimeters. Now these are for screw holes, so what does that tell you? No, it's 2.5. And anyone know what 2.5 has to do with screws? That's the drill size for an M3 screw. So that means we can self-tap the screw directly into the wood. So we start out with a 2.1, add 0.4 to get 2.5, and that's the hole we should drill so that we can self-tap an M3 screw. Now say this is the part above this. Now it's going to be 3 millimeters, goes to 3.4 millimeters, and that is so that our bolt can go through without touching the sides and interfering. So I understand it seems perfectly random at first when you're like, wow, why is that 2.6 and 2.1? It's because when you add the 0.4, it has actual physical meaning.
So it's 2.6, not 2.26, right?
2.6.
Okay.
Yeah.
And I think you drew it wrong. It seems like the dimension on the laser diameter would be 0.4. Because you're getting half of the diameter on the left side.
Oh yeah, you're right. Sorry about that.
When should they change the colors of the holes in the appearance?
Yeah. I only do that if there's something special about it. My convention is blue for like a special type of fit, like a press fit or a slip fit, and red for tapped. And that way, if the hole is the same color as the rest of the part, I know not to worry about it. So red, I guess I should have put that in the homework. Red for tapped, blue for press fit or slip fit.
Shouldn't be that the radius is 0.4.
I don't know.
Yeah, it should be diameter 0.4.
Yeah, that's true. No, you're right. John's right. Because then there's a 0.2. So we add 0.2 here and 0.2 here to 21.6 and we get 22. Any other questions about Lab 1? Let me just tell you now, you're all doing very well. You really are. But you're still learning. You're still new to this. It's going to take you forever to do this CAD. So, not Shruti. She's nodding her head.
No, I'm just agreeing with you.
Oh.
It's taking forever to
Okay.
do this lab.
Okay, yeah. So here's the thing though. Because the reason why I decided to give you so many gears is one, because there are lots of gears, but B, because I want to get this over with, the first lab. I don't want you to still be learning SolidWorks for the second through in labs. That sucks. Remember this curve in terms of effort versus time here? You're right here. We're here at night tonight, we're here at night tomorrow night if you want to for Masumi, but after that, I promise, no more night visits. And then after this lab, you guys are going to be good at SolidWorks. I'm serious. Like, you just have to do it over and over until your finger hurts, and then you're good. So that's what this lab does. There are, let's see, you have 16 shafts to install. That's 16 chances to practice what we did tonight. And when you're in the lab, that means you cut 16 shafts, chamfer 16 shafts, install 32 bearings. I mean, it's hardcore. So it gives you a lot of practice, but then after that, you're never going to ever wonder about bearings or SolidWorks or hole tolerances ever again, because you will have done it. It's like you will have been doing it for a year in one lab. So that's why it's painful. Lab 2 will be a lot less painful than this, because you already know SolidWorks and there'll be a lot less parts that we're cutting. Okay, unless anyone else has questions, let's adjourn. Yep.
Well, not related to this actually.
That's fine.
The Masumi talk tomorrow.
Uh-huh.
You're gonna post it online, right?
I am.
So, is there any advantage to coming in?
No.
Oh.
Let me turn off. Let's see.